This is lesson 1-4 about powers and exponents. You'll notice that this is non-calculator, so you're not to be using a calculator while we do this. You shouldn't need a calculator while we do this. Okay, so here we go. A power is an expression written with an exponent and a base. For example, this is 8 to the third power, and this means 8 to the third power means 8 times 8 times 8. Notice there's no equal sign. When there's no equal sign, that is an expression. In this example, 8 is the base and 3 is the exponent. The base is the number that is being raised to a power, and the exponent is the actual value of the power. Okay, so we're going to look at some patterns here of powers so we can understand how this works. So we're going to start with 3 squared. Okay, this is 3 squared, 3 to the second power. 3 to the second power is the same as 3 times 3, which is 9. 3 to the third power is the same as, I'm going to put it out here, do it right here. 3 times 3 times 3, which is 27. 3 to the fourth power, 3 times 3 times 3 times 3, which is 81. And 3 to the fifth power, 3 times 3 times 3 times 3 times 3. A little off there. And that is going to be 243. Okay, so let's take a note, or let's take a look at the pattern here between these numbers here. So how do I get from 9 to 27? I multiply times 3. How do I get from 27 to 81? Times 3. Okay, so every time I go up a power, I am multiplying by 3. Why am I multiplying by 3? Because that's my base. It does not have to do with the exponent, it has to do with the base. So I multiply by 3 every time I add a power. Every time I increase the power. When I increase the power by 1, I'm multiplying by 3, which is the base. So what happens when I go backwards? What happens when I go from, for instance, 81 to 27? Well, this time I'm dividing by 3. Same thing when I go from 27 to 9. I'm dividing by 3. Guess I should put arrows here. So this is going back, and the other one is going forward. Okay. So if this is the pattern, if this is the case, then what's going to happen when I go back from 3 squared to 3 to the first power? Well, I'm going to divide by 3. So what is 9 divided by 3? It's 3. So that means 3 to the first power is 3. What happens when I go back one more? Divide by 3 again. What's 3 divided by 3? 1. 3 divided by 3 is 1. So that means that 3 to the 0 power equals 1. It does not equal 0. So hopefully that helps you. Okay, so let's take a look at evaluating powers. It says you must pay careful attention to the use of parentheses when evaluating powers. Okay, so the first example is pretty simple, 4 to the third power. 4 to the third power is the same as 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. That one's pretty simple. Now let's take a look at -4 to the third power. Now, this negative sign does not apply to the exponent. What I mean by that is the only thing that is being raised to the third power is the 4. So this would be the same as if I wrote it like this. The negative sign is outside the parentheses. So I'm not going to do negative 4 times itself times itself. I'm doing negative 1, basically, times 4 times 4 times 4. Well, we know 4 to the third power is 64, so this has a value of 64, and if I multiply 64 times negative 1, then I get negative 64. Now over here, this specifically has the negative 4 in parentheses, then with the 3 on the outside as the exponent. So what does this mean? This means negative 4 times negative 4 times negative 4. Okay, so what happens when you multiply a negative times a negative? You get a positive. So when you multiply a positive times a negative, you're going to get a negative answer. So the answer here is going to be negative 64. So you'll notice that these two answers are the same, but that is not always the case. In fact, let me give you an example when that's not the case. So let's say I have negative 4 to the 6th power and negative 4 to the 6th power. Okay, so this means 4 to the 6th power and then times negative 1. So 4 to the 6th power is 4,096. Times negative 1 is going to be negative 4,096. Okay, so now this is negative 4 to the 6th power. So I'm multiplying negative 4 times negative 4 times negative 4. That's 3, 4, 5, 6. Well, we know that 4 to the 6th power is this number right here, 4,096. So the only thing we really need to worry about here is what is the sign going to be? Well, let's see. Negative times a negative is a positive. Negative times a negative is a positive. And a negative times a negative is a positive. So positive, 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 when you multiply it, is going to be a positive answer. So this is going to be positive 4,096. So notice these are not the same answer. So you need to pay attention to the parentheses. All right, let's go back. Let's take a look at this one. It says 2 to the 3rd power over 3. So in this case, the only thing I'm raising to the 3rd power is the 2. 2 to the 3rd power is 8 over 3. 8 over 3 cannot be simplified, so that would be my answer. This one has the fraction in parentheses, so that means this is the same as 2 to the 3rd power over 3 to the 3rd power, which is going to be 8 over 27. Can 8 over 27 be simplified? Well, factors of 8 are 1, 2, and 4. And none of those go into 27, so that would be your answer. Now this one, this is not number 5, okay? This 5 is in front of the parentheses. This exponent does not apply to this 5. This 5 is kind of similar to this negative sign in front right here, which we made into a negative 1. So this 5 is on the outside, so this is 5 times, well, we know 2/3 to the 3rd is 8 over 27. So 5 times 8 over 27. Remember, a whole number has a denominator of 1. So that's like 5 over 1 times 8 over 27, which is going to be 5 times 8 is 40 over 27. I don't believe there are any common factors, so I do think that would be your final answer. Okay, your practice problems are from page 29 of section 1-4 under exercises. You need to do numbers 5 through 14 all of those problems. It shouldn't take you very long at all. You need to have those answers recorded. And then I need you to answer this reflection question. What can you conclude about negative numbers raised to an odd and even power? You need to write a couple complete sentences about what you notice about raising these negative numbers to either an odd power or an even power, and be prepared for that to be checked in class. Good luck.